So when we're solving rational equations, it's pretty much the same process as solving any other equation, like a polynomial equation. It could involve factoring. If it's linear, it could just be isolating x. But you also have to keep in mind that with rational equations, you're going to have denominators that you have to deal with as well. So the big change here is that you're going to have to deal with denominators as well. And those are going to lead to some restrictions of what x cannot be, where vertical asymptotes or holes or undefined values happen on the graph. So let's take a look at our first example, x plus 1 over x equals 0. This is a fairly simple rational expression in terms of x plus 1 just being a linear equation, and then x obviously being linear as well. So what we can do is we can think about, well, where would the x-intercepts for this graph be? Where would y equal 0? Well, that happens when the numerator equals 0. To solve, then, a rational expression, they really just want you to set the numerator so we'll say set a equal to 0. If our function, our rational equation, looks like a over b, you're just setting a, the top, equal to 0. So if x plus 1 equals 0, that means x equals negative 1. But we also have to think about restrictions. What can x not be? Well, we know that x cannot cancel out with x plus 1. X equals 0 is a vertical asymptote, which means, stated as a restriction, x cannot equal 0. Okay, so for number 2, we're going to look at a little bit more of a complicated quadratic on the top. X squared minus 3x plus 2. So we're going to be factoring just like we do with a normal polynomial. But on the bottom, we're going to have x minus 1, and this equals 0. So we're going to start by factoring the top. This is a simple factoring question. X minus 2 times x minus 1. Negative 1 times negative 2 comes out to positive 2. And negative 2 minus 1 is negative 3. And on the bottom, we still have x minus 1, and this all equals 0. So what you'll notice is that there is an undefined value. X cannot be 1 is a restriction, which means it also cannot be an x-intercept. But when you can cancel out factors like this, when you see it in the numerator and the denominator, that means that this value is actually a hole in the graph. So not a full vertical asymptote. You wouldn't even be able to see it unless you zoomed in and you clicked right on that point in Desmos. When x equals 1, you would have an undefined value. So a tiny little pinprick. It's not going to be a vertical asymptote or anything fancy like that. And in fact, this graph is going to look identical to the straight line y equals x minus 2. It's just going to have an undefined value at x equals 1. So if I solve for the numerator, I already know that x minus 1 can't be 0, but x minus 2, if I set that equal to 0, that gives me an x-intercept of positive 2. So in summary then, if you can cancel out factors, that means that you're going to have a hole in the graph, and this reduces down to a nice linear equation, and x equals 2 is my solution, and x cannot be 1 is my restriction. Okay, number 3, we're getting a little bit harder now. 1 over k equals 1 over 2k minus 1 over 4. So what you'll notice here is now we have just numbers on the top and we have some letters on the bottom. So we have to come up with a common denominator here. So the lowest common denominator for k, 2k, and 4 is 4k. Because 4 is the largest number, 2 times 2 would give us 4, and this is just a 1. And then each of these has a k. So the last one will also have to have a k. So the lowest common denominator is 4k. And we're going to rewrite everything with that common denominator. So 1 over k is the same as 4 over 4k, just multiplying top and bottom by 4. 1 over 2k is just 2 over 4k, just multiplying top and bottom by 2. And a quarter is the same as k over 4k, multiplying top and bottom by k. But we can hopefully see right away that k cannot be 0, or that would break these two fractions here, because 1 over 0 or 1 over 2 times 0, that's going to be bad. So we already know what the restriction is. So now we're going to bring together my fractions on the right hand side. So I've got a common denominator, so I can bring these together as a single fraction, 2 minus k over 4k. And now that the denominators are the same, I can set the numerators equal to one another. So 4 has to equal 2 minus k in order for this to be true, since the denominators are already the same. And then I can solve. So 4 minus 2 equals negative k. And I'll just switch sides here. K equals negative 2. So k equals negative 2 is like my k-intercept, or my intercept with the axis, the independent axis, and k cannot be 0. All right, so moving along to a harder example. Number 4 is going to have a little bit more excitement in terms of the common denominator. So negative 2 over x squared equals x plus 1 over x plus 2 over x. So hopefully right away you can see that x cannot be 0 and that the lowest common denominator is x squared, because both of the fractions on the right hand side have an x and we have an x squared on the left hand side. So I'm going to do a little bit of a different approach here. I'm going to multiply everything through by x squared, the common denominator. So I'll do that in a different color. So I'm going to multiply the first one by x squared, the second, and the third, all three of those fractions by x squared. So I've got x squared times negative 2 over x squared equals x squared times x plus 1 over x plus x squared times 2 over x. And then I can do some canceling. I notice there's an x squared that can cancel with the x squared there. X goes into x squared x times, so I got rid of the exponent, and same thing over here. X cancels out with one of the x's up there and leaves just an x. So multiplying out, I now have just negative 2 equals x times x plus 1 is x squared plus x, and then plus 2 times x, so 2x. So my final answer then, if I rearrange this and set it equal to 0, I'll be able to factor it from there and solve it just like a polynomial. So x squared looks like I have 3x. This is all on the right hand side, and then I'm going to bring over and make that plus 2 equals 0. And then I can factor. So x plus 2 times x plus 1 are my factors. So x can equal negative 2, or x can equal negative 1. So those are my two x-intercepts, and as well I'll just restate that x cannot be 0 is my restriction. Okay, one more to go here. So the very last one that I want to look at is 1 over x plus 1 equals 2x over x squared minus 3x minus 4. And this is one where you're really looking in the denominator for factoring instead of in the numerator. So I'm going to leave the left-hand side for right now, and I'm just going to start by factoring. So the bottom of, or the denominator of the second fraction, the right-hand side, I can simple factor that and make it x minus 4 times x plus 1, because negative 4 times positive 1 is negative 4, and negative 4 plus 1 is negative 3. And then that gives me this common factor of x plus 1. So I don't want to start multiplying right away, or I'm going to end up with this big messy cubic. Instead, factor and see what they already have in common. So x plus 1 will definitely be in that lowest common denominator, but it's only going to show up once. So there's got to be an x plus 1, and there has to be times an x minus 4. So the right-hand side is already in really good shape. All I have to do is multiply both sides by x plus 1 times x minus 4. So I'm going to just shrink that down a little bit so I can just add in. I'm going to multiply this by x plus 1 times x minus 4. And whatever I do on the left, I do on the right as well. And that's perfect because on the right-hand side, both the factors in the denominator cancel out with both of those factors. And the x plus 1 cancels out with the x plus 1 here. And so I'm just left with an x minus 4 on the left-hand side. And on the right side, I'm just left with a 2x. So it simplifies really nicely. And then the final step, just rearranging and isolating for x. So I've got 2x. I'm going to subtract x on the other side. So it looks like x is going to equal -4. I will just switch that around. So x equals -4. And if I look at my restrictions, in factored form, I know x cannot be +4 and it cannot be -1. And that's because of the restrictions that I got from the denominator here. And the same restriction of x cannot be equal to -1 is happening over on the left-hand side as well.